Hi, Algebra 1. I'm going to go ahead and get started with our review. As I'm working through this review, I am going to do question 1A, and then I'm going to ask that you pause it and work on 1B. Then we'll work on 2A together, and then pause that and try 2B. Okay, there's going to be two videos, one on the first page, and then there will be another one for the second page. Okay, so on this first one, let's get started with 1A. Alice spent $131 on shoes. Sneakers cost $15 and Fits cost $28. If she bought a total of 7 pairs of shoes, how many of each kind of shoe did she buy? Which equations could be used to represent the amount of each shoe purchased and the cost of the shoes in total? So remember we talk about that. I know these are word problems. We can go ahead and go through, underline the information that is important, and then cross off what's not necessary, boxing any of those numbers. So let's see. I'm going to go ahead and look for the question first. Which equations could be used to represent the amount of shoes purchased? So there's one question. And then the other question, the cost of shoes in total. Okay, so if we're looking for amount of shoes purchased, has nothing to do with cost. She bought a total of 7 pairs, and she bought sneakers, and she bought Fits. Now, when we're talking about cost, let's see. Let me pick up a red pen. Fits cost $28. Her total spent was $131, and sneakers cost $15. So the parts that I've highlighted, or if you box them, that's one equation. What's in yellow is one equation. What's in red is the other equation. So what's not important to me here at this point? Just what, let's see, how many of each kind of shoe did she buy? All right, that is a question, but I'm looking at the answers, and that part there I should have left out, okay, because that's kind of irrelevant here, because they told us how many she bought altogether, and none of these answers talk about just Fits or sneakers. Okay, so the first one, how many of each, or the amount of shoes purchased? Well, she bought some sneakers, which is the S, and she bought some Fits, and their total is 7. So I'm looking for ones that have a total of 7. All right, so it's possibly this one, possibly this one, possibly this one. Now, the reason that I'm going to take out E is because when I'm looking for total, I'm adding. Okay, and that one there is subtracting. So I know it's not E. Okay. So it's got to be C or F. And in this case, it is going to be C, because C is just talking about the number of flats and the number of sneakers, where F is talking about the cost of the sneakers and the cost of the flats, and I know that that doesn't equal $7. Okay. Now we're also talking about the money she spent. Well, she spent a total of $131. So again, she's got to be adding the pieces together. D is not adding, D is subtracting. And when I look at A and B, because they both equal 131, A is only talking about the amount. It's not talking anything about the cost. So my two equations in this case are going to be B and C. Okay. All right, so now I'd like you to pause this video and go work on 1B. Okay, so for 2A, Miss Bastian and Miss Garrett, so Miss Bastian and myself went to the candy store. Miss Bastian bought 5 pieces of fudge and 3 pieces of bubblegum for a total of $5.70. I bought 2 pieces of fudge and 10 pieces of bubblegum for a total of $3.60. Which systems of equations could be used to determine the cost of a piece of fudge and a piece of bubblegum? So we've got to make sure that we're creating the right equations. All right, so looking at the answers, is there anything I can eliminate that I can say already doesn't make sense? Yes, I'm going to say A, because Mrs. Bastian and I each have our own equation, but we didn't both spend 570. Okay, so I know it's not going to be A. All right, looking at B, C, and D, one of us spent 570, one of us spent 360. All right, so Miss Bastian bought 5 pieces of fudge and 3 pieces of gum, and she spent 570. So when you're purchasing things, you're adding the money so you get the total. So now when I'm looking at B, I can see that it's not B because we are not going to be subtracting. We need to be adding to get to the total. Okay. All right. Again, Miss Bastian bought 5 pieces of fudge and 3 pieces of bubble gum. 5 pieces of fudge, 3 pieces of bubble gum, and she spent 570. So that part's correct. I would have bought 2 pieces of fudge, 10 pieces of bubble gum, and I spent 360. Okay. So that's definitely a contender. Now let's go look at D. Well, D says that she bought fudge and bubble gum, spent 570, but we don't know how many pieces that she bought. So it is not going to be D in this case. So our only option is C. All right, go ahead, pause the video, try 2B, and come back and let's work on 3A. Okay, for 3A, Kelly can work for her dad and make $6 per hour, or she can work for Jenna's mowing service and make $14 per hour. She needs to make at least $84. Oh, that's an important word. I'm going to go ahead and underline that. At least. That tells me that I'm dealing with an inequality. Okay, and one of her totals is $84. And she can only work, okay, 10 hours. So she can't work more than 10 hours. She can work at most 5 hours for Jenna's mowing. Okay. Let X represent the number of hours that she can work for her dad. And Y represents the number of hours she can work at Jenna's mowing. Okay. Which inequalities can be used for this situation? All right, so let's see. If we're talking about Jenna's, and we're talking about her dad, the total number of hours and we're talking about total money. All right, so these pieces of information are going to be important. Total hours, she can work only 10 hours. So whatever she works has to be less than, or it can be equal to 10 hours. Okay. She needs to make at least $84. So she wants the money to be greater than or equal to $84. She doesn't want to have less than $84. All right, so I'm going to go just using those 2 pieces. I'm going to see if I can eliminate any answers. Well, A says that she can make less than $84, but not equal to. So I can eliminate A. B is the same thing. It says she's going to want to make more than 84. Just looking at the inequality sign, I know that's wrong. Okay. I need my inequality to be equal to for both equations. So I can take off A and B without even looking at anything else. All right, money. When we're talking about money, she wants to have the money be more than $84. All right, well, this one says less than $84. It's not going to be that one. So looking at C, 6X. Well, 6 represents the dollars per hour that she can work for. Who's X again? X is her dad. And Y is Jenna's. Okay, so she can make $6 an hour for her dad, plus $14 an hour for Jenna's. So that equation is good. And then looking at those two, 104. 104 is not any of our totals, so we can cross off that one. So our equations are going to be C and E. Okay. All right, go ahead and pause the video and go work on 3B. All right, looking at 4A, Letitia wants to buy pumpkin and autumn squash for a fall display. She has a budget of no more than $117. All right, no more than 117. Okay. And she wants to buy more than 10 vegetables for the decorations. Pumpkins are $5.50 each, and the squash is $3.50 each. Which of the inequalities represents the constraints of the numbers she can purchase? All right, so she's buying pumpkin and squash, and she wants to have more than 10. So P and Q are going to be added, and it has to be greater than 10. All right, P plus Q is greater than 10. P plus Q is greater than or equal to 10. P plus Q is greater than or equal to 10. And P plus Q is less than or equal to 117. So I'm going to go ahead and cross off D right up front. Okay, she wants to buy more than 10. So if she wants more than 10, she doesn't want it to be equal to 10. So I can already cross off B, already cross off C. My only option in this case is A. Let's just go ahead and check that second equation to make sure that it's true though. So pumpkins cost $5.50. That is true. Squash are $3.50. That is true. We're adding them, and the amount that she spends can be no more than 117. Well, this here says that it can be greater than 117, so that one can't be it. So let's see. I'm going to go back and look at my other answers and see if there's something that I might be looking at. I'm going to look at C and D again. Okay, let's see. I'm actually seeing a typo on my end because this should not have been greater than or equal to. It should have been less than or equal to. Okay, for that one to be correct. So let's correct that. Otherwise, if it was B, yeah, it would have to be A, but my inequality is backwards. Okay, so I'm going to go ahead and put A here. Go ahead and work on 4B. Okay, 5A. The following system of inequalities is graphed on the graph. Which region of the graph represents the solution to the system of inequalities? First off, remember, whenever we're graphing, our systems need to be in slope-intercept form. A is already in slope-intercept form, but with the second equation, we've got to move that negative 2x to the other side, and then we have to divide everything. So let's do that first. So we have negative y is equal to, not equal to, is less than or equal to 2x plus 4. Then we are going to divide by negative 1. Every term gets divided, and this is when we're going to flip the inequality. When you multiply or divide by a negative number, you flip that inequality. So then we will have y is now greater than or equal to negative 2x minus 4. Okay, let's go ahead and graph them. The first one, our y-intercept is at positive 1. And the slope is 1/2. Means it goes up 1, right 2, up 1, right 2. Okay. So with that equation there, y is greater than the graph of the inequality. Okay. All right, so our second equation starts at negative 4, and it would have a negative slope of 2/1. And on that case, we are going to be shading a y is greater than. So I'm looking for the area or the region where the two colors overlap. And in this case, that region is going to be A. Right? Go ahead and pause the video and work on 5B. All right, so let's look at 6A. Okay, so, excuse me, we have 3 diagrams here that we're looking at, and we're trying to find the pattern and which equation works with that pattern. So what I'm going to go ahead and do is just count up the boxes in each pattern, or in each image. So this first one has a total of 4 boxes. This one has a total of 7 boxes. And this one has a total of 10 boxes. Okay. So because I know this is a concept that in class we only very briefly covered, I want to look at it and say, how in the world, if I got stuck on a problem like this, how could I use what I can in my toolbox to find this answer? Well, I have to determine what I think the variable n is talking about. Okay, so the first 3 terms of a sequence, if the pattern continues, which of the following formulas determines the number of boxes in the nth term? Okay, so n is talking about the different terms. Okay, so when we're looking at these terms, I have the first term, the second term, and the third term. Well, if I wanted it to equal 4, could I plug in 1 for that and get an answer of 4? So let's see. What if I did 3 times 1 plus 4? What does that equal? That gives me 3 times 1 is 3 plus 4 is 7. Well, my first box, or my first term, does not have 7 boxes. It has 4 boxes. So that one doesn't even meet the criteria for the first term. So there's no reason for me to check it for the other 2 terms. All right, let me check B. What if I did 3 times 1 plus 1? Does that equal 4? Yes, that does equal 4. Okay, so if it works for that one, let's go try it for the second term. 3 times 2 plus 1, does it equal 7? Yes, it does. So it still works. And now let's try it for the third term. 3 times 3 plus 1, that does equal 10. Okay, so B appears to work. Let's just check the other ones to make sure. Again, using our answers to help us, but checking still. So if I have 3 times 1 plus 3, 3 times 1 is 3, plus 3 would give me 6. That is not what I need, so it's not going to be that one. All right, and then this one here, if I did 3 times 1 plus 2, that gives me 5. My first term has 4 boxes, so this one doesn't work either. Okay. All right, so I'm going to go ahead and let you pause here, work on number 6, and I'm going to stop this video and I will start a second video for the second page.